We have created our cube. Now it is time to learn a bit of programming. Sometimes components are not sufficient for us to build a feature. We need to implement those features by ourselves. To do that, we will write Unity scripts. Scripts are just like components, but they are not pre-prepared and they need to be coded by the developer. For example, there isn't any component that changes the game object's position or rotation in the runtime. Or there is not any component that spawns a predefined cube in the game environment. For these specific tasks, we need to code our logic. Scripts can be applied to game objects and modified in the inspector panel. In Unity, the script is made up of C# code. Don't worry if you do not have any experience with coding or you do not need to learn. You can find the written scripts in this course from the resources folder. Let's create our first script. We will first create a folder in the project and call it scripts. Enter. Let's open this folder and creating new C# scripts. I will call this as move script. Enter. Let's attach this script to the cube from add component and typing move script. From now on, any code we write in the script can easily access the cube and change its properties. Let's open the script. It is ready. Now that we have our script attached to the cube, let's look at the two very important functions that are included by default in every new script: start and update. The start function is called when the script is first run. This is where you can initialize any variables or set up your game object when the game begins. Think of it as the place to put code that you want to execute at the very beginning. As an example, let's first print a message to the console which can help with debugging. Debug.log. The game has started. Now we will set the position of the cube to 0, 1, 0 in the scene. We can access the attached game component by typing transform. To access the position, scale, and rotation, we can put a dot after the transform and type the requested property. Therefore, to change the position of the cube, we need to write transform dot position equals to new vector tree parentheses 0, 1, 0. And this code line sets the initial position of the cube to the origin 0, 1, 0. In Unity, vector tree is a structure used to represent 3D points and directions. It consists of three values, x, y, and z, which correspond to the 3 dimension of the 3D space. Since position, scale, or rotation are vector tree data structures, we need to define them as vector tree. Let's test this and see if it works. We will save the script with Ctrl S and then go back to Unity and run the script. As you can see, the cube is at 0, 1, 0 after the game runs. When we stop the game, the cube turns back to its original. Now it is time to learn the update function. We will go back to code. The update function is called once per frame, which is 30 or 60 times in a second, depending on the FPS. This is where you put code that you want to run continuously throughout the game. Anything that needs to be checked or updated regularly, like user input or moving objects, goes here. Let's write similar code as before. In the example, debug.log will print a message to the console every frame, which can help you see how often the update function is called. And the line transform.position plus equals new vector 3 moves the cube slightly to the right every frame. It is time to test. It is important to note that the first start function will run once, then the update function will run continuously until the cube somehow gets destroyed or we stop the game. Let's Ctrl S and go back to Unity. Okay, let's run the game. As you can see, it is moving to the right by 0.01 in every frame. You can also check the console that there is printed once the game has started and 1000 times this runs every frame. Let's also change the position with the local scale corresponding to the scale to see what happens. Ctrl S. Now we will run the game again. As expected, it gets bigger and bigger on the x-axis. You can try it with rotation or change other axes as well to explore. Now we will turn it back to position right now. We have learned how to programmatically move our cube, and now it is time to explore physics in Unity using colliders and rigid bodies. These components will allow our game objects to interact with the physics engine, making our cube behave more realistically in the game world. We will start with the collider. A collider is a component that defines the shape of a game object for physical collisions. Colliders do not have any visible representation in the game view. They are purely for collision detection. And rigid body is a component that allows a game object to be affected by the physics properties, such as gravity, mass, or drag. It makes the game object move realistically according to the physics game engine calculations. Let's first add a collider to our cube. First, select the cube from the hierarchy if it is not selected. There are many collider shapes, such as box, sphere, and capsule for 3D. Since our cube has the shape of a box, we will use a box collider. Now you can press Add Component and type Box Collider. However, we do not need it because the box collider was already added by default when we were creating the cube, if you remember. From now on, we know that our cube will collide with other colliders with respect to its bounding box, which can be seen from the green lines around it. We can change the collider size or adjust the center. Now it is time to test rigid body. Ensure the cube is selected in the hierarchy panel still. In the inspector panel, click on Add Component. Type rigid body in the search bar and select it. By adding a rigid body, we have now enabled physics for our cube. It will be affected by gravity and other physical forces. Let's hit run and see what happens. As we can see, our cube is falling because of the gravity. To test the colliders, copy the cube by pressing Ctrl D after selecting it. And place the copy cube 3 units on the below side of our old box. Also, do not forget to remove the script component from the copy cube because we won't want them to go right together. Let's hit play. Since both are affected by the gravity, they both started falling. Therefore, we couldn't see any collisions. To see a collision, let's stop the gravity effect on the copied cube. When we press run, we can now experience a physics interaction simulated in Unity. You can try other rigid body attributes, like fixing the position of the copied cube. In this case, cube will only rotate due to collision, just like in a real-life fixed object. Now let's go for a more famous approach for most of the games. We will use a plane for our platform, so that cube will fall on a plane and will not infinitely fall. Now we can delete our copy cube. Then right-click in the hierarchy and press 3D Objects and Plane. We can set its position as 0, -1, and 0. As you can see, by default, the plane has a special collider named as the Mesh Collider. And it is very accurate since it perfectly matches the shape of the object. Let's run and visualize the interaction. We can even make this plane bigger by arranging its scale to have more flexibility in the scene. Rigid bodies are essential for any game object you want to move or be affected by physical forces, like gravity, collisions, and other interactions. It bridges the gap between Unity's physics engine and the game object's transform component. From the inspector, you can set the game object's mass, air resistance, in other words, the drag, the existence of gravity for that object, and many more. From a script, you can even do more advanced stuff, like apply a force to the rigid body with the add force function, or directly set the rigid body's velocity with velocity method. We will not go any deeper into physics and leave it here. However, if you are interested, you can test yourself with the properties of colliders and rigid bodies, or write some script to manipulate the cube's physics.